In the last lecture, we finished this example. It's about making a committee. And now we have another example. In the example, it says a student is required to answer 7 out of 12 questions, which are divided into 2 groups, each containing 6 questions. That means here we have 2 groups of questions. Each one contains 6 questions, this 6 and that 6. The student is required to choose 7 questions from these 2 groups, which each one is 6 questions. It says the student is not permitted to answer more than 5 questions from either group. That means the student can choose either 1, 2, 3, 4. Sorry. He must choose at least, at most 5 questions from this one. And also at most 5 questions from this one. The student is not permitted to choose or to answer more than 5 questions from each of these 2 groups. Okay? But because the number of questions that's required, the student must answer, 7 questions. At each case, the sum of answered questions must be 7. That means in the case when the student choose 5 questions or answer 5 questions from this one, the student must answer 2 questions from this group. That means always the sum of all answered questions must be 7. Okay, and when the student choose 4 questions from this group, so what's the rest of questions that the student required to answer? 3. Because the sum of both must be 7. And when the student answers 3 questions from this group, so how many questions from the other group? 4. And when the student answers 2 questions from this, it's 5. Can the student answer 1 question from this one? Let's see. How many more questions for the other group? 6. But the student cannot answer more than 5 questions from either groups. That means we have not this case, 1 and 6. We have only these 4 cases. Okay? That means if the student answer 5 questions from this group, so the student must answer 2 questions from this group to answer 7 questions. And then if the student answer 4 questions from this one, so the student must answer 3 from that group to complete 7 questions. So now we have these 4 cases. We have these 4 cases. Okay, in the first case we have as here we have no ordering. We have no ordering. Okay, that means we use combinations. For this one, 5 out of 6 multiplying by 2 out of 6. Okay, at each case we multiply them. That means it's C 6 and 5 multiplying by C 6 and 2. So what's the result here? And then at this case, when the student answers 4 questions from a group and 3 questions from the other group, in this case we say the student, let's say if the student answers 4 questions from this one and 3 questions from that group, we say it is the combination of 4, so it's 6 and 4 multiplying by combination of 6 and 3 equals to what? In the third case, if the student answers 3 questions from this group and 4 questions from the other one, this is the combination of 6 and 3 times combination of 4 and 3. So it's 6 and 4. We have one more case, which the student answers 2 questions from the first group and 5 questions from the second group. This the combination of 6 and 2 multiplying by combination of 5 and 2. We have only these 4 cases if the student answer 7 questions, such a way that do not answer more than 5 questions in either group. Yeah, it's 6, sorry. It's out of 6 and 5. Thank you. This equals to what? Now we find each. You find each of them, the combination of 6 and 5. I'm just gonna do one of them and the answer for the others. Okay? We say it equals to 6 factorial dividing by 5 factorial multiplying by 6 minus 5 factorial. This is the rule of combination. So the rule of combination, we say C, N, and R. That means choosing R things from N. It equals N factorial dividing by R factorial multiplying by N minus R factorial. That's the rule for combination. We just apply that rule and we get, here we get 6. So it's multiplying by, it's for this part. And for this part, we say, here we just multiply both cases, both in each case. We have this choosing our questions and this one also. In this case, we multiply both combinations. It's multiplying by 6 factorial dividing by 2 factorial times 6 minus 4 factorial. Okay, we find it. The first one is equal to 6 multiplying by. Here we have 6 factorial dividing by 2 factorial times 2 factorial. Here 6 minus 4 factorial means it's 2 factorial. Okay, 2 times 2 is 4, and the above one is 6 times 5 times 4 times 3 times 2 times 1. That is 6 times, I'm just gonna do it here. We have 6 times 5 times 4 times 3 times 2 times 1. And in the denominator, we have 2 factorial times 2 factorial. Each one is 2 times 1, so the result is 4 here. This 4 with this one are cancel out. Here we have 6 times 5 is 30, times 3 is 90, is it? Times 2, 180. Okay? Is it? So now the result is 180. Let me check. No. Just 90. Why? Okay. We have 180 divided by 4. Okay. In the denominator is 6 times 180. Is it? 6 times 180 is, let me check why it's 90 here. 5 from this group and 6 from that group. It is 6 factorial divided by 5 factorial times 1 factorial. So it is 6. And the other one is 6 factorial. So it's 2. I did a really big mistake actually. Yeah, we say the combination of 6 and 2 is 6 minus 2 factorial, not 6 minus 4 factorial. That's why I had a mistake. Here in the denominator we have 4 factorial times 2 factorial. 4 factorial with these are cancel out. And here 2 factorial is 2, with 6 is 3. 3 times 5 is 15. And now we have 6 times 15, which is 90. Okay, this is for the first one. For the others, it's the same. We just apply the rule, okay? And we get 300s, 300s, and 90. We now add these results. We add all cases. First, for each case, we multiply them. And then we add all cases to find the number of ways. Here, 90 plus 300 plus 300 plus 90 is 780. So that means here we can, the student can answer the 7 questions in 780 ways, such that not more than 5 questions from each group. Okay, this is the number of ways that the student can answer the questions. Okay. Do you have any question about that? Okay. Now we have combinations if the repetition is allowed. We say we use this rule for finding the combinations when the repetition allowed. Here we say the number of R combinations of n objects. That means we choose R from n. We choose R from n objects. Here we say if the repetition allowed, we say the combination of n plus R minus 1. Before, without repetition, we said is C, N, and R. Okay, but now, if the repetition allowed, we say the C, N plus R minus 1, then R. That means you replace N by N plus R minus 1. And we apply the same rule. See, it equals, in fact, N plus R minus 1 factorial, dividing by R factorial, multiplying by N minus 1 factorial. Okay, it's N minus 1 factorial. Because if we say N minus, here, this is N. This is minus R factorial. It's the same as to say N minus 1 factorial. Okay, because here we have N plus R minus 1 minus R factorial. These are cancelled out and we get only N minus 1 factorial. Okay, so this rule is used for find the combination if repetition allowed. Just replace N and R, that's all. Okay, here we have an example. It says, let's say there are 5 flavors of ice cream: banana, chocolate, lemon, strawberry, and vanilla. We have these 5 flavored ice cream. You can have 3 scoops. You can have only 3 scoops. It's possible if all three scoops from one type of the ice cream. Okay, and it's possible if 2 of them from one type and the other one from the another type. And it's also possible if you take each scoop from one type of the ice cream. That means here repetition is allowed. Repetition is allowed. Okay. So it says in how many variations will be there. That means in how many ways we can take 3 scoops of ice cream. As I said, it's possible if we take all 3 scoops from one type of the ice cream. That means here repetition is allowed. Okay, since the repetition is allowed, so we apply the repetition of combinations because here we have no orderings. So now we should identify R and N. What's R here and what's N? As you see, we take 3 from out of 5. Okay, we take 3 out of 5. So here R is 3 and N is 5. We just replace R and N by their values in the rule. Here the rule is, we say C n plus r minus 1 and r equals, it equals to, so let me just write down it, just replace r and n by the values here. It is n plus r is 8 minus 1 is 7, so c7 and 3, so it's combination of 3 of 7. It equals to 7 factorial dividing by 3 factorial times 7 minus 3 factorial. That's all. Just do it, you get the rest. 7 minus 3 factorial is 4 factorial, we get 7 factorial dividing by 3 factorial. It's 3 factorial times 4 factorial. As I said before in the previous lectures, we are going to expand the above one up to the highest factorial on the denominator. That means 7 times 6 times 5 times 4 factorial. Dividing by 4 factorial, multiplying by 3 factorial. These two are cancelled out. And what we get in the denominator, 3 times 2 times 1 is 6. This is 6, is it? 3 factorial is 6. These two are cancelled out, and you get 7 times 5, which is 35. That's 35. That means the student, 3 scoops can be taken in 35 ways. Okay? You can take 3 scoops of from 5 type of ice creams in 35 ways. Okay? Do you have any question about that? Look, here we have on the example. It says a bakery makes 4 different varieties of donuts. Khairin wants to buy 6 donuts. How many different ways can he do it? As you see here, it's possible if Khairin chooses all 6 donuts from one type of the donuts. Okay, and even he could choose 3 from one type and 3 from the other type. That means repetition allowed here. So what's R here? R is 6. What's N? N is 4. Okay, do it. Do it by ourselves in groups. We use this rule C, N plus R minus 1 and R. So what's R and what's N? We just replace them by their values. N is 4 and R is 6. We say it is C, the C of N is 4 plus 6 minus 1, which is 9. 9 and R is 6. It equals to 9 factorial dividing by 6 factorial times 3 factorial, because 9 minus 6 is 3 factorial. It equals to 9 times 8 times 7 times 6 factorial dividing by 6 factorial times 6. These two are cancelled. Here 3 factorial is 6, and it equals to, these two are cancelled out. This becomes 3 and this becomes 4, and here these two also, it becomes 3. 3 times 4 is 12 times 7 is 84. That means the result is 84. So the result is 84. That means in 84 ways, those 6 donuts could be chosen from those 4 types. Okay, this is the result. We have on the example, it says there's a box containing identical blue, green, pink, yellow, red, and dark blue balls. So how many colors do we have? Look, it's 1, 2, 3, 4, 5, and 6. We have 6 types of balls, okay, which is classified by their colors. In how many ways we can select 4 balls? As you see here, we have repeated colors here. For example, may there are 10 blue balls. May there are 4 yellow balls. Okay, so it's possible to choose all the 4 balls from the same color. Okay, all the balls could be yellow. May 3 of them could be one color, and the last one is different from them. And may each one from different colors. That means here it's possible to choose the same color for each ball. That means repetition allowed here. Repetition allowed. ليرة أساي أجر همون توبا كان يقرن كوشي. شو قال شو عطوا بمبول بجير. شو عطوا بقى نيوتوا شنيان فلان رقبة شنيان فلان. كأول ترى يكسر permutation بكارين مرجيت يعني. Okay. Ordering هبو مرج هبو يكسر شيء بكارين permutation. فلان ليرة نوترا على شو عطوا بمبودر بير. أكيد شو عطوا بقى دوباره بن على. أكيد دوباره. كواتا لير نوترا وربتشين الله ديانا. فلان هما بسيارك أزانين كرجة بيدرا والتوبك بدن يقرن دوجا دريبين سيجا دريبين أسايا. Okay. Here, what's R and what is N? N is the color of the balls. Here we have 1, 2, 3, 4, 5, and 6. That means N is 6. And R is the choose ones. So R is 4. What we do, we apply the same rule as we did before. This C of N plus R minus 1 and R. N is 6. R is 4. We just replace N and R by their values, and this C of N and 4, 9 and 4. Here we get C 9 and 4 equals to this. It's 9 factorial dividing 4 factorial multiplying by 9 minus 4 factorial, which is 5 factorial. It equals to 126 ways. That means we can choose 4 balls in 126 ways. Okay. Do you have any question about these? Here we talked about 3 examples of combination if repetition allowed. It's actually 4 questions. Okay. We talked about 4 questions about combinations if repetition allowed. Now we have a list of exercises. That's for yourselves. Try to do it by yourselves. Okay. And now we have part 3 of chapter 3. Part 3 is about pigeonhole principle. Pigeonhole principle. Here, it's only an introduction of pigeonhole. You can read it by yourselves. Here, I'm going to talk about what's pigeonhole principle. We say, imagine we have 9 pigeonholes and 10 pigeons. بمعنى كوتر دليل. باشا. دو فما هاد بكريكشن. Here we have 9 pigeonholes and 10 pigeons. A storm comes along and all of the pigeons take shelter inside the pigeonholes. Look, we have pigeonholes بڵین هێلانەمان هەیە و بڵین کولانی باشە نۆ کولانەمان هەیە لەگەڵ دە کۆترە ستۆرمێک دێت ئەمانە بێ هەموو بچنە ناو کولانەکانەوە بەڵام ئەکری هەموویان بچنە یەک کولان وایە ئەکری هەرێکیان بچێتە کولانێک بەڵام چیمان هەیە لێرە لانی کەم یەکێک لە کولانەکانە بێت چی تیا بێت زیاتر لە یەکدانی تیا بێت since here we have 10 pigeons and 9 pigeons as you see here pigeonhole 1 pigeonhole 2 3 4 5 6 7 8 9 so we have 9 pigeonholes but we have 10 pigeons that means all the pigeons will go into one pigeonhole and each one go into one pigeonhole. But here we have 10 pigeons. That means there's an extra pigeon if each one goes into different pigeonholes. That means here this one should go into one of those pigeonholes in this case. That means there is at least one pigeonhole which 2 pigeons in. Okay, here we have at least one pigeonhole that have at least 2 pigeons. کاتە لێرە لانی کەمێکە لە کولانەکان چەند کۆتری تایە دوانی تایە بۆ لەوەی دەدانەمان هەیە نۆ وایە لەوانەیە هەموویان بچنە یەک کولانە بەڵام لەوانەشە هەرێکی بچێتە کولانێک بەڵام یەک دانە زیاد ئەی بچێتە شوێ بچێتە لە دانەیەکان کاتە لانی کەم یەکێ لە کولانانێک کە هەمانە ئەبێت چەند کۆتری تیا بێت 2 okay so here we say that's it here we have 10 pigeons could be inside one hole and also the rest of the holes could be empty and also here we say one hole so there is at least one hole that contains more than one pigeon here the pigeonhole principle is working on the pigeons and pigeonholes if the number of pigeons is greater than number of pigeonholes by 1 I mean if the number of pigeons to be in and the number of pigeonholes to be n minus 1 that means here you have 1 extra pigeons regarding to the pigeonholes if you have let's say 20 pigeons okay if you have if we have 20 pigeonholes so how many pigeons must we have here we must have 21 pigeons we must have 20 we always must have 1 extra pigeons from the number of pigeonholes okay here as you see this shelter contains 2 pigeons but others each one contain 1 okay you say if n pigeons fly into k pigeonholes and k is less than n here always the number of pigeonholes must less than the number of pigeons some pigeonhole will contain at least 2 pigeons that means if the number of pigeonholes is less than the number of pigeons so here in this case there is at least 1 pigeonhole which contains more than 2 pigeons for example let's say if you have 12 pigeons and they say 8 pigeonholes let's do it Here you have 8 pigeonholes and 12 pigeons. If we put these pigeons into these pigeonholes, so here there is at least 1 pigeonhole which contains at least 2 pigeons. For example, let's say it's 1, it's 2, 2, 2, 2, 1, 1. Okay, here as you see, there is at least one pigeonhole which contains at least 2 pigeons. Okay, كانت اللاني كم يكل pigeonhole كان بلاني كم يكل pigeonhole كان بشيتيا زياتر ياخذ دو يعني زياتر شيتيا pigeon يعني بنمنا أقبلين أما هم يكمل. Okay, this one 1 1 1 2 3 4 5 6 7, so it could be 5. Okay, this could be 5. As you see here, we have at least 1 pigeonhole which contains at least 2 pigeons. Here we have 5 pigeons. That's more than 2, so that's correct. Okay, here the pigeonhole principle of first form. Here we have 3 forms of pigeonholes. The pigeonhole principles. The first one is, it says if n pigeons fly into k pigeonholes and k is less than n, that means some pigeonhole will contain at least 2 pigeons. This is the principle. Okay, so if you have k pigeonholes and n pigeons, such that the number of pigeonholes is less than the number of pigeons. In this case, some pigeonhole will contain at least 2 pigeons. Here you have some notes about the pigeonhole principle of first form. It says the principle tells nothing about how to locate the pigeonhole that contains 2 or more pigeons. So here the principle is doesn't care about which of the pigeonholes contain at least 2 pigeons randomly, any of them. Okay, it's only care about there is at least 1 pigeonhole which contains at least 2 pigeonholes. It only asserts the existence of a pigeonhole containing 2 or more pigeons. To apply this principle, it's important to know which objects are the pigeons and which objects are the pigeonholes. In the example, it may not be given as pigeons and pigeonholes, may be given by other objects. Okay, so it's important to know that which objects are pigeons and which objects are pigeonholes. Here you have an example, some examples actually. You have among 8 people, there are at least 2 persons who have the same day of the birthday. Look, you have 7 days. Okay, you have 7 days in a week. The number of days in a week is 7 days, and here it says we have 8 people. Among 8 people, there are at least 2 persons who have the same day for their birthday. That means here it's talking about the number of days in a week. In a week we have 7 days. Okay, from Monday to Sunday. So here we have 7 and 8. Which one should be pigeon and which one should be pigeonholes? Okay, the greater one is pigeons and the least one is the pigeonholes. So here the pigeonholes is the number of days, 7, and the pigeons is the number of people, 8. Okay, so here it's important to know what's pigeon and what's pigeonhole. Here we have another example. It says among 13 people, there are at least 2 persons who whose months of birth is same. We have 13 people and 12 months. So how many months do we have? 12. So which one is pigeonhole and which one is pigeon? The greater one is pigeon and the least one is pigeonhole. Here we have 13 people and 12 months. So this is pigeon. This pigeonhole. And this is pigeon, that's pigeon. The greater one is always pigeons because we say pigeons fly into the pigeonholes and there is one extra. So one of the pigeonholes must contain more than one pigeons. Okay? So here it's important to determine what is pigeonholes and what's pigeons. Here we have an example. It says in a party there are n people. There are n people. Prove that there are at least 2 persons who know exactly the same number of people. Okay, we have n people in the party, and we should prove that there are at least 2 persons who know the same number of people. We have the pigeons is the number of people who's known by anyone. Okay, this is the pigeonholes, and the pigeons is the number of people. It's the number of people. So the number of people is n, and the number of people which is known by anyone is pigeonholes. Why? Because if you have 4 people and each one know the others, so each of them know each of them. Now, how many people? Each of them knows 3 people. Is it? For what? For now, in that example, the pigeonholes is 3. As I said here, we have 4 people. Each one know others. That means here this person knows this, and each of them know 3 people. So here 3 is pigeonholes. Which one? Okay. But here we have n people. Among n people, there are 2 people who know the same number of people. For example, here we have, let's say, 25 students. 25 students. May only 2 of you has relations with the same number of others of students. Okay, may you have relation with 5 of them. May another one have a relation with 5 of them. That means here there is at least 2 students here who have relations with the same number of other students. Okay, this 2, it means there are 2 people who know the same number of people. So here pigeonholes is the number of people who's known by any of them. That means n-1, because here we exclude him or herself. Because if, as in the example, as I said, if you have 4 people, each of them knows others. That means each of them knows 3 people. So him or herself is excluded. That's why we have n-1 for the pigeonholes, which is the number of people known by others. And the pigeons is the number of people that we have n people in the party. We say if a person knows I people, if a person knows I people. Then the person is put into the I box. If a person knows I people, then this person is in the I box. In the I box. Look, let's say this is. Just imagine the pigeonholes. Okay. Let's say we have this. If each of these contain person, okay, even there may have more than one people in each of them, and we say if a person knows I people, then this person should be put in I, let's say here. That means you have two. So each pigeonhole contains those people who know each other. That means here, at least here you have these two persons that know each other and don't know others. So here we have at least two people who know the same number of people. Each of them know only one. Okay, each of these knows only one. La boxy aya duka sitia. كواتا أم دوكا ستنها خوان كده ناس كسكنا ناس. كواتا تنها تعرف يعني خوانها. كواتا هري كان شو كذا ناس. يكس. كواتا شو ما نقوله. So here there is at least two people who know the same number of people. Okay, so that's the answer. Okay. Look here, it's just imagining about pigeon and pigeonholes. Okay, here we have pigeonholes as the noun people by any of them. Okay, and pigeons are the number of people. Pigeons are the number of people. We say if a person knows I people, then the person is put in the I box. In the I box. That means here there is at least one box. So there must be one box which contains two persons. That means here there is a box which contains two persons. That means there are two people. Since here there are two people who know the same number of people. Okay, so that's it. Do you have any questions about that? Okay, let's take a break. Then we will continue. We now have a pigeonhole principle of the second form. In the first form, we said we just care about if we have at least two pigeons in one of the pigeonholes. But here, in the second form of pigeonhole principle, we say if we work on the functions. Okay, if is a function from a finite set x. Yeah, this is a finite set x to finite set y. We have x and y. F is a function from x to y. Okay, here we have x and y. F is a function from x to y. And the cardinality of x is greater than the cardinality of y. That means the elements of x are more than the elements of y. The number of elements in x is more than the number of elements of y. Yeah, this is the cardinality. For the cardinality, we say it is the number of elements. The number of elements in x is greater than the number of elements in y. Here, let's say if we have 1, 2, 3, 4, 5 if we have 5 pigeons and 4 pigeonholes, as you see here, as you see, this is x and that's y. F is a function from x to y. In x, we have 5 elements, and in y, we have 4 elements. If we define any function from x to y, there must at least 2 pigeons which go to the same pigeonhole. Okay. As you see here, here we have 5 pigeons and here we have 4 pigeonholes. If we draw the arrows from pigeons to pigeonholes, so there must be at least 2 pigeons which arise arrow to the same pigeonhole, yeah. چی معنی لێرە؟ ئەگەر f فانکشنی بێ x و بۆ y ژمارە ئلیمێنتەکان x زیاتر بن لە ژمارە ئلیمێنتەکانی y کەواتە هەر فانکشنی پێناسە بکەین لە x و بۆ y چی معنیاتێ؟ ئەو معنیاتێ کە لانێکم 2 ئلیمێنتی x ئەچم بۆ چی؟ بۆ 1 ئلیمێنتی y. Okay, here we say if f be a function from x to y where the cardinality of x is greater than cardinality of y. So then f of x1 equals x2, where x1 doesn't equal to x2. That means 2 different elements in x have the same image. At least 2 different elements of x has the same image. This is the principle. This is the principle. If that means if you have a function from x to y such that the cardinality of x is greater than cardinality of y, it means we have at least 2 different elements in x which have the same image in y. Okay, we say the second form can be reduced to the first form by letting x to be the set of pigeons and y to be the set of pigeons. Assign pigeon x to pigeonhole f of x. Pigeon to be x and its pigeonhole is f of x. Because f of x belongs to y. Yeah, it belongs to x. So there's an arrow from x to f of x. That means this is the pigeon and that's the pigeonhole. By the first form principle, at least 2 pigeons, let's say x1 and x2 in x, are assigned to the same pigeonhole. It's by the first principle, by the first form of the pigeonhole principle. That's f of x1 equals f of x2 for some different x1 and x2. Here we have an example. In the example, we have given a set A. It says, show that if we choose any 4 distinct members of A, if we choose any 4 distinct members of A, then for at least 1 pair of these 4 integers, their sum is 7. Yeah, let's pick any 4 from set A. Let's say x to be 1, 2, 3, 4. We choose these 4 elements. May someone else choose another 4 elements from set A. It says here we have at least a pair of the elements x such that their sum is 7. Look, 1 and 2 is 3, 1 and 3 is 4, 1 and 4 is 5. But here we have at least 2 elements such that the sum of pairs is 7. Unless you get x set a big at the tashes. Our actual element will begin them set. Actual element will begin them set. Lanicam do element tia surgery. Okay. Look, let's solve it here in a long way. I'm gonna solve it easier. Okay. Let me find some space here. That's it. Let's solve it here. Here, set A is 1, 2, 3, 4, 5, and 6. This is set A. It says if we pick any 4 elements from A, that means there's at least 2 elements in those 4 elements, which their sum is 7. Let's see. We say let's first find those pairs which their sum is 7. We have 1 and 6. Their sum is 7. Then 2 and 5. Their sum is 7. 3 and 4. Their sum is 7. Do you have any more? Do we have any more pair which their sum is 7? Hiç do element ektirim here koy her dükkan kata how? There is no. That's all. Okay. Here we have only 3 pair which their sum is 7. We let Y to be this set. We let Y to be this set. Let's say this is Y. Y to be this set, which is 1, 6, 2, 5, 3, 4. And if we pick any 4 elements from A, we denote by X. Okay? If we pick any element, any 4 elements from A. Okay. Someone tell me any 4 elements from A. You say it's Y to be this. And X, someone give me 4 elements from A. Any 4 elements from 1 to 6. Okay. 2. What else? 5, 6, and one more. 1. Here we pick these 4 elements from set A. We say X to be this set. 1, 2, 5, 6. This is the set. Now we denote a function f from x to y. F from x to y, such that we say f of A to be, see, for all x, for all A in X, f of A belongs to a pair, one of the pairs. Okay, f of A, I mean A belongs to one of the pairs. F of A equals one of the pairs where A belongs to the pair. There are a function كنا function f بجوري في هر element x كاتا شي كاتا أوجو ترى خراوي كشي تيار كأو point تيار. Okay, so what's the image of 1? It is 1 and 6. Why? Because 1 belongs to 1 and 6. What's the image of 2? 2 and 5. What's the image of 5? It's still 2 and 5. What's the image of 6? 1 and 6. Okay, so here this is the function. This is the function, and we say this function from x to y. X is any 4 is the set of any 4 elements of A. As you see here, there is at least 2 elements in X, which moves to the same, which have the same image. As you see here, we have 1 and 6. 1 and 6 have the same image. 1 goes to 1 and 6, and 6 goes to 1 and 6. That means here there is at least 2 elements in. There is at least 2 elements in X, such that the sum of them is 7. As you see here, 1 and 6 have the same image, which is 1 and 6. 2 and 5 have the same image, 2 and 5. That is here, we have at least a pair of elements in X such that their sum is 7. Let's speak on the subset of X, of A. Let's say it's to be 1, 3, 4, let's say 5. Here you have these 4 elements. We choose under 4 elements. 1 goes to where? 1 and 6. 3 goes to 3 and 4. 4 goes to 3 and 4. And 5 goes to 2 and 5. Do you have any 2 elements in X which have the same image? Yes, 3 and 4 have the same image. That means here we have a pair of elements of X such that their sum is 7. Yeah, 3 and 4 goes to 3 and 4, and 3 plus 4 is 7. That means there's at least 2 elements in X such that their sum is 7. So that's all. Okay, but here it's explained all steps. That's all. Okay. So here we say this function from X to Y. What's the cardinality of X? This 4. And what's the cardinality of Y? 3. You have 3 elements in Y and you have 4 elements in X. Since the cardinality of X is greater than the cardinality of Y, so we have at least 2 elements in X such that their sum is 7. That's all. So this is the answer. You can just write down this, what I have written down here. If of A equals, let's say, A, B, or BA, where A belongs to AB or BA. That's it. So this is the answer. Look here, solve it in 3 slides. You can use what I have written down here. It's easy. Do you get that? In this example, what we did, we just first write down those pair which their sum is 7, and we name it Y. And then if we pick any 4 elements from X, we can define a function from X to Y such that f of each element of X is the pair in Y which the element is in. Okay, if the such that the element is in the pair. That's all. We now have another example. It says, using instant messaging, every Sunday evening, 10 friends communicate with each other. Instant messaging allows a person to open separate window to each person he or she is communicating with. Then, at any time, at least 2 from 10 friends must be communicating with the same number of friends. As you see here, we have 10 friends. These 10 friends are messaging to each other. Each one can talk to each of them separately. And it says at least two friends must communicate with the same number of the other friends. Okay, for example, let's say 2 of them are communicating with 5 of them at the same time. We say we let x to be x1 up to x10. These are the number of friends. X1 is the first one, second one, up to the 10th one. With a set of 10 friends. For each xi, let ni be the number of friends they are communicating with. Here, let's say for x1, let's say if for x1, for student number 1 is communicating with 5 people, 5 persons, let's say n5. Okay, that means here x1 is communicating with 5 of the friends. A person may not be communicating with any person. So it's possible if we have one of the friends which is not communicating with any of them. That means here n is 0, is it? You have n0 also. Continue. And also, we may have a student who is communicating with 9 people. Since we have only 10 people, only these 10 people can communicate with each other. That means a student, it's possible if a student don't communicate with any of them. So the number of communicating in this case is 0. If a student communicating with only one person, the number of communicating for this student is 1. And then if the student is communicating with 2 people, with 3 people, with 4 people, up to 9 people. No students can communicate with 10 people because one of them is their selves. That's why there are only 9 people to communicate with. Okay, so here you have these number of communications. That's either 0, 1, 2, up to 9. We have only 9 options for communicating. A student may don't communicate with any of them, but my student communicate with 5 of them, with 6 of them, with 9 of them. Okay. So we have 0 to 9. We have 10 number of communications. We say we let y to be from 0 to 9. We let y to be from 0 to 9. I'm gonna draw the diagram here. Here you have y from 0 to 9. 0, 1, 2, 3, 4, up to 9. Okay, this is y. And x is the students. As you said, we have 10 students. We have x1, x2, up to x10. This is the set of students. Okay, when we draw, let's say x1 to 2, that means x1, the student x1 is communicating with 2 people. If we have, let's say, x2 to 0, that means x2 doesn't communicate with any of the students. Let's see if we have x3 also. If x3 goes to 4, that means x3 means student number 3 is communicating with 4 people. Okay, here we have the possibilities of communicating. Now, how many elements do you have in x? What's the cardinality of x? It's 10. How about the cardinality of y?
10.
It's 10. It's still 10 because we have 0 also. Here we have the same cardinality. So in this case, we cannot apply the Pigeon principle. What we do, we say, we suppose that one of the students don't communicate with any others. Okay, one of the students don't communicate with any of the others. That means here the number of communicating reduced to 8. Okay. For example, if you have 6 people, these 6 people are communicating to each other. If one of them don't communicate with any of the others, that means there are only 4 people to communicate with, 4 others. That means, yeah, if we have 10 people and one of them doesn't communicate with others, so you have only 8 people to communicate with. That's it. Okay. Now we have the cardinality of y is 9. We have 9. So in this case, we say the cardinality of x is less than the cardinality of y. So it's greater than. It's greater than cardinality of y. We can apply the Pigeon principle of second form. We say if we have 2 sets and f be a function from x to y, such that the cardinality of x is greater than cardinality of y, then we must have at least 2 elements in x which have the same image. Let's say we may have these 2 elements which goes to the same number. We may have another 2. Let's say here we have x7. X7 and x3 goes to 3. That means here x3 and x7 are communicating with 3 people. We just apply the principle. You say applying the Pigeon principle second form, we get that there is at least there exists x1, let's say xi and xj in x, such that f of xi equals f of xj. It means that there are two students who communicate with the same number of students. Okay, so that's all here. And instead of using the solution here, you can use what I have written down here. We have a function from x to y, and we said since the number of elements of x equals to the number of y, so we suppose that one of the students doesn't communicate with any others. In this case, the number of communications is reduced by 1. So it becomes 8, from 0 to 8. Here we have 9 elements in y and 10 elements in x. So you can apply the second form of Pigeon principle. And you get that there is at least 2 elements in x which have the same image. It means at least 2 students are communicating with the same number of students. So it's enough for today.